Yeah, so we have a couple of minutes left until we start. Thank you already, all of you that so timely arrived. That's very much appreciated. I hope some more are coming now that I hear outside the bell ring. And yeah, any of you are already test containers users? Show of hands. Any test containers users here? Yes, thank you. This side of the room, no test containers users? Okay, I hope maybe after the talk we will have some more raised hands. And you there, you're happy with test containers or test containers users? Are you happy test containers users or not happy? Unhappy test containers users? So didn't you raise your hand as a test containers user or not? Yeah? And you're happy with test containers or not? Yes? Okay, that's good. Good to hear. If you're not happy, come after the talk, tell me what you don't like. Maybe there are ways for us to improve. Oh, hello, hello. I hope you all come to sit down in this room and not pass through into the other room. That would be heartbreaking for me. Should I start? Yeah? Okay. Okay, cool. Hello, welcome to my session. I'm happy that you joined me for the last talk of the conference, and I hope you still have some good energy left for a very fun topic we will talk about, which is testing, software testing, and the history of some software testing concepts. Name of the talk is Curse of the Pharaohs, Rethinking the Testing Pyramid with Test Containers. So we will not only talk about the history and the theoretical stuff, but also have some concrete examples with some Java-related technologies, namely test containers. All right, and I have this remote, so I can press here actually. So a little bit about myself. My name is Kevin Wittek. I'm nowadays suddenly an engineering manager at Docker. Last year I still was an engineering manager at Atomic Jar, which is a startup we built around the open source project Test Containers. So Test Containers, pure open source project. That's what I will also talk about a bit in this talk. But in the startup Atomic Jar, we tried to build some commercial products around and on top of this open source project. And last year we got acquired by Docker, which of course is nice since as a technology, Test Containers always was very related to Docker. So that's how I ended up at Docker. I'm still one of the Test Containers maintainers though. I'm leading the Test Containers team at Docker. Yeah, some people say when I still had my mustache, I used to look like a Barish Mancho, and I even played together with my wife and my band a Barish Manchu song at my wedding. What is it? Tomates, biber, patlijan. It was very fun. So yes, I approve. So this is a very nice talk from Donald Knuth that I'm not going to show, but I'm just putting here as a reference for you and maybe have a look at it. And it's called "Let's Not Dump Down the History of Computer Science." And he gave it as part of a Turing lecture. And what he talks about there is more or less that fact that in computer science and software engineering nowadays, we don't have a real academic discipline regarding the history of computer science, regarding the history of software engineering. So nowadays, if we look at the history of software, it mostly looks at how software impacts and relates to society, how it changes industry, etc. But it doesn't look at the history of the computer science itself. It doesn't look at the history of how certain algorithms got developed, like that a certain algorithm maybe was developed by id Software back then when they developed the first version of Doom to render 3D graphics without 3D cards and so on. And he says that's something that generally happens in a lot of disciplines. The more disciplines get applied in society and in technology, the less the field actually has its own history, and like historians only look at how these technologies, how these fields impacts other parts of the world, of society. And a nice counterexample is actually mathematics. So in mathematics, we have a very rich history of how mathematics itself, mathematic methods developed over times, and through this we learn interesting stuff. So we learn that, for example, the concept of Fibonacci numbers was not only developed in the Middle Ages, basically, or in the Renaissance by Fibonacci, but also many, many years, hundreds of centuries, no, not hundreds of centuries, centuries ago in India. We also had this concept of Fibonacci sequences in merge. And yeah, it would be very nice if we as the industry, software industry and computer science would become better in understanding our own history of our field, because through this we can learn from the history, we can see how things repeat, why certain movements suddenly start to push certain stories, certain narratives, and also looking at certain hype waves. So we have currently this big Gen AI hype wave. It's very good to see, for example, look into the history of AI development. We had these hype waves before. We had them in the 60s, we had them later in the 80s, whatever. So yeah, that's just a little bit fluff here, and I really recommend this talk. So we will now look a bit into the history of testing in the concept of Java, especially unit testing, integration testing, and some things that appear in around this whole narrative. And I'm of course not really a historian, I'm a software engineer, but I try to look into the history where certain concepts first emerged. And one really good source for this is Kent Beck that established the JUnit framework. And who here uses JUnit? Yes, okay, and the ones not using JUnit, you are not testing or using something else? Who is not testing? Oh, some people not testing. And who uses something else instead of JUnit? Nothing. So there are either JUnit users or people that don't test, it seems. That's at least the situation in Java. And how did Kent Beck came up with JUnit as a concept, as a framework? So Kent Beck, as an object-oriented programmer, started originally in Smalltalk. And Smalltalk itself already had a very rich testing culture, but a different testing culture to what we know today. So back then in Smalltalk, a lot of the testing was done manually. And that worked very well because in Smalltalk, you have the stateful workspace. Similar if any of you ever used something like MATLAB or like a Jupyter notebook where you execute code and the code changes the state of the environment, and then you just inspect, okay, what is currently happening in the environment, what are the values of the variables, etc. That's how it was, in R it's the same. And that's how it was done in Smalltalk as well. So people execute some Smalltalk code, call some methods, and then they inspect, okay, how did the state of the object change? And then in 1992, Kent Beck developed the first object-oriented unit testing framework, and they took the concept we had in Smalltalk and put them into code concepts. So the workspace became essentially the test suite, the objects, that you were normally inspecting became your test class, and then the test methods became the code you would normally manually run. And this testing framework was developed in the C3 project, which is super interesting because it's one of the projects where all these nowadays famous agile and extreme programming people worked. So Kent Beck was there, Martin Fowler were there, and others, and there they developed this framework. And his idea was always like, okay, if developers need a testing framework as part of the project, they will probably develop their own testing framework with certain concepts. And yeah, then later on the flight to a conference together with Eric Gamma, who is famous for domain-driven design book, and also one of the architects behind Visual Code, he, during the flight, used TDD, a TDD, test-driven development approach, to actually develop the first version of JUnit. So they took the flight, then they arrived there, and then he gave this first version of JUnit to Martin Fowler, and he checked it out and said, oh, yes, nice, and that's how it started. And nowadays, it's a kind of de facto industry standard in Java, as we just saw. Right. So, unit. So this was called JUnit. So maybe this has something to do with unit testing, maybe not. We will look in a bit what unit testing actually means. Before we look at this, what is about the concept of test-driven development? So many, if they do test-driven development, assume test-driven development is a method that is used in the context of unit tests. But Kent Beck himself says it's important to test at different scales, in different orders, which of course means like lower level code details, but also out-of-box stuff, integration tests, etc. And test-driven development itself is not a unit testing philosophy. It's a testing philosophy. So you can use it for all kind of testing scales. And interestingly, JUnit, and JUnit 4 in this case, has been developed completely using TDD. And 40% of the tests inside the JUnit internal test suite are tests through the public API, and that are not tests you would classically characterize as unit tests. So the tests, a big chunk of the tests of JUnit themselves are not unit tests, and they have been written with test-driven development. So that's first very good to be aware of this. And when they then first developed this JUnit testing framework, together with Eric Gamma, they went ahead, they did consulting as trainers to people kind of teaching developers, oh, you can also write tests yourself. Because that was something that before JUnit came into existence was not something that developers usually would have maybe done. So they would have said, okay, testing is for the testers or whatever. And so they wanted to find out when they joined companies to do consulting there and people were not writing tests, okay, why didn't they write automated tests for their software? And basically it had to do with the fact that writing tests was cumbersome, was not easy, was error prone. And then they come up, and this is from a paper they published, they come up with this very nice sentence. We found the outside influence we needed in a simple testing framework that lets us do a little testing that makes a big difference. So you need to change something in the environment that motivates the people to do testing, to make testing easier, in a way to make testing simpler. It's like related to what Venkat said this morning. So I already asked you, like, who of you uses JUnit? Some do, some don't, so maybe some of you test, some don't test. What are generally reasons why people test their code? Like maybe you want to find bugs, or you want to add the test suite after you've written your code to safeguard against future regressions when you make changes. I mean, sometimes you just write the test because the boss says, oh, we need 95% code coverage, so just write tests. And that are the most beautiful tests that are written then. And yeah, some people don't test. So maybe some of you that didn't raise your hand, you don't test. You say like, okay, I don't have to test. Like either the testers will test or later my users will test. So when they put the stuff into production, at one point people will test it and you will see if stuff works. So I personally love testing because for me testing is the best and fastest way to get feedback about the correctness of my code during development. So testing is for me personally part of software development. I cannot imagine doing software development without testing. And even if you do something like you run your code, you run your application, you click around in the GUI and then you check that certain logs are printed, that certain things change in the application, that is also testing, right? That is manual exploratory testing. But I find this a little bit boring and cumbersome. That's why I personally prefer automated testing a lot. And yeah, so when is the best time to write tests? There's a nice article from, it's actually the same, no, that is a wrong reference here, sorry. There is an article from Martin Fowler, what is in his opinion the best time to write tests? So whenever you are like wondering, okay, what is this code actually doing? Do I have a bug there or not? Or maybe I should add some print statements. Instead of doing the print statements, you can actually write a test, and then you get the tests basically for free that are used to explore the correctness of your code. So that in effect means the most valuable point in time to write tests is during the development and then when you're doing the debugging, because tests are the fastest way to get the feedback about the correctness and the correctness of the changes, and that changes don't break anything else. Now, I promised we will look into the definition of unit testing, what unit testing actually means. And if you try to find the canonical definition of unit testing, that's not easy because there is none. And I looked into the academic literature, what computer science papers and so on, how they define unit testing, and you find vastly different definitions. And here's one definition from an IEEE article, what is software testing and why is it so hard? And this one is a very interesting, weirdly interesting definition. So it says unit testing tests individual software components or a collection of components. So what does it do? Individual things or a collection of things? That's like kind of the one thing. A collection of things sounds more like an integration test because now you are testing the integration of this collection, but whatever. That's how they define it there. And then the last one is very interesting. Unit testing sometimes requires the construction of throwaway driver code and stubs and is often performed in a debugger. So I've never ever in my entire career did unit testing in a debugger. I, of course, used a debugger for understanding why I have bugs or whatever, but I never did my unit testing within a debugger. I do my unit testing within a unit testing framework or whatever. But yeah, so that's what you see there. And then, okay, that is academic. Let's look into the industry. Maybe the industry has a clear definition about what unit tests are. And of course not. So there is another interesting paper where they did a survey across a range of different companies to understand how they define unit testing, and the results of the survey, like you had a very, very broad range of answers. So there was an agreement in the survey that unit tests should focus on the smallest possible unit possible. And I don't know why, but there seems to be the sentiment, this is the case, which, however, is in disagreement with what it says here, that it can be a collection of components, but doesn't matter. And then, independent of this, in the survey there was a big disagreement with regards to the degree of isolation that there should be between the different units that are tested. So some say, okay, this unit is not allowed to interact with other units. Others said like, no, it's okay, you can test a set of classes or whatever. So no clear answers there as well. Okay, let's dive a bit deeper and find out what was the first occurrence of the word unit in the context of testing. And I'm not guaranteeing that what I found here is the first occurrence, but it's the first occurrence I found. And that is from a paper from 1978 called Automatic Software Test Drivers. And in this paper, another document is referenced, a manual from IBM that is called the Automate Unit Test System. And I have not found this document for this IBM system, so I don't really know how this system defines unit, but it's what I could find in all the papers, the first usage of the word unit. Now, if you look just 1 year later, there is a very, very famous book that was famous in the testing community before like testing became also part of what the software development community does, that's called The Art of Software Testing. So the first edition, 79, and there is a chapter there that is called Module Testing. So in this book, 79, there is no mention of unit testing. Now something important, in my opinion, happened, and that was in the 90s. Thanks to Kent Beck and other in the Agile community, we have the creation of these XUnit frameworks. So it's JUnit, NUnit, or however they are called in the different languages. And now, what does unit mean in this context? So there are also different definitions. Some of this agile circle say the unit can mean the unit of test code that is executed. So maybe it's not the code under test that references unit here, maybe it is the test code itself that means unit. But whatever. The interesting thing is that this basically started to cement the usage of unit testing within the software industry. And then in 2004, we see that the second edition of this, The Art of Software Testing book, renames the chapter module testing to module unit testing. And the content is more or less the same. But yeah, that's why, in my opinion, the 90s and the rise of those X-unit frameworks really established the word unit tests. Still, the meaning was not clear across all people. Okay, so we now confused ourselves a little bit about what unit testing actually means. Let's make the confusion even bigger by putting unit testing into relative perspective with other kinds of testing like integration testing, functional testing, and so on. So many of you probably know the software testing pyramid, which is kind of industry de facto standard, seems to be common knowledge. Okay, software like this pyramid is how you should compose and distribute your test suite. Let's look at how this originated, because it's not that old actually. So my personal hypothesis is that it has been motivated by the food pyramid as the metaphor. And this food pyramid, it's from the 70s or 80s, this is the US version. And the interesting thing, this food pyramid has been made by the United States Department of Agriculture. So that in a way explains why at the bottom we have like bread, cereal, rice, pasta, so everything that is produced by the agricultural industry. So that's why this pyramid has back then been pushed into the consciousness of the society of how the healthy food composition looks like. And of course nowadays we know that's not the ideal food pyramid for you. And the reality is much more complex, and I don't even know what are correct models, probably some kind of circles or whatever. But based on this metaphor, we see now the software testing pyramid in a way also emerge. And I have another example afterwards that even shows more clearly the relationship between the two. So what I found, the first occurrence of this testing pyramid, test automation pyramid, is probably around 2003, so not that old actually. And this 2003 version might be originally envisioned by Mike Cohn, that also wrote the user stories books. So again, someone from the Agile community. And so there is this mythology around this, that he showed it to Lisa Crispin, someone else from this Agile cycle, on a conference or on a whiteboard. He scribbled it, and Martin Fowler says, oh, he saw this in 2003. But that's mythology. Where we then see it in printed form is in the book Succeeding with Agile, Software Development Using Scrum, and that was 2009. And that is this very classic version. So you have like the bottom unit test, you should have mostly unit tests, like the healthy foods, right? Then the middle is service test. Okay, what is service test there? The definition in this book is a little bit fuzzy, but it's probably something that nowadays you would define as integration test. What is integration test? I don't know. In this example, it is test that goes through a public API, and then at the top you have the UI test. So now it's important to understand the context, why this pyramid has emerged back then, and why people thought it's a very good way to educate developers with such a pyramid. And that is because before Agile came up, there was this narrative that writing tests is very expensive. That's why developers should not write tests. And automation is very expensive. It's very error prone. That's why it doesn't bother to invest automation. And then a lot of those Agile people back then said like, no, we have to look at it more in a more differentiating way. So only certain kind of tests are expensive to write, expensive to maintain, and these are the UI tests. So if we focus on mostly writing UI unit tests that are cheap to run, easy to maintain, then it's fine. Then we get a lot of value of testing, and that's why this symbol was then communicated a lot in these communities, in these agile communities, extreme programming communities, etc. But of course, there are more variants of this pyramid, and that is another very early version I found from Jason Huggins, 2006. He's the person that later developed Selenium. And here is a cute thing we see that it says at the top, UI test, smoke test, salts and fat used sparingly. So that's very clearly the reference to this food pyramid metaphor. And yeah, it says, okay, unit test, used lots and lots of unit tests, that are the healthy food. And then in the middle, something here defined as functional tests using PIT, which is a Python testing framework. Functional tests, again, something nowadays we would maybe call integration tests, whatever integration test means. Besides these more simple models, there have always been ways to model it more complex, and I personally like it. So we have Lisa Crispin, which we already heard before, and Brian Merrick came up with this concept of agile testing quadrants. And that I find personally much more valuable because it already shows a little bit that defining the class of a test is a much more multi-dimensional thing. So in the testing pyramid, we have basically one dimension. So you go from on the y-axis, right? At the bottom you have unit tests, and you go up and up and up, and kind of complexity grows, or whatever is the y-axis here representing. But here these testing quadrants already show like, oh, there are very, very different dimensions to tests. So tests might be business-facing. They are there to critique the product. So for example, benchmarks, they critique the product, how fast runs your product. And yeah, I like this a lot. That's why you then end up with unit tests in the one quadrant. Other tests end up with performance tests and so on. Okay, but the testing pyramid prevailed, and here is another very famous example from Martin Fowler. We are now in 2012. The interesting definition here is, if my tests are fast, reliable, and cheap to modify, then lower level tests are not needed. So here we already see there are certain constraints that are involved in choosing this testing pyramid, and that are the assumption that the unit tests are fast to run, cheap to write, cheap to maintain, and the higher we go up, the more expensive everything becomes. If through whatever reason my hardware gets faster, my tooling gets better, it's suddenly possible to also write and maintain and execute service tests, integration tests, UI tests in a cheaper way. Okay, why not write those tests? Because they give me maybe more confidence. And that's something good and important to keep in mind. We also had people kind of trying to challenge the testing pyramid. This is from Simon Brown. That says like, oh, like these definition, unit tests, integration tests, functional tests, they are not very fuzzy. Let's try to find new definitions. And then he used this testing house, and they come up, okay, like if we just test a class, it's a class test. If we test a component, what is a component, what is a service? So it's another kind of fuzziness, and it was not really adopted by the community, by the industry, but still, it's good to challenge this truth of the pyramid. And this, personally, I like a lot. This is a testing funnel, and the concept of step-up testing, first shown in an article by Cindy Sridharan in 2017, and this is about testing of distributed systems. What are distributed systems? Microservice architectures. So the moment those microservice architectures became more prevalent, it seems it made sense to again rethink the classical testing pyramid and the constraints that shaped this testing pyramid. So in one essence of this article that says, okay, what does step-up testing mean? It says, always test one layer above what you traditionally think is the layer you should test. So traditionally you think, okay, I do unit testing, I mock away all the interactions with other systems, with my database or whatever. But she says, no, it's much more valuable in a microservice world, in a distributed systems world, to do, instead of unit testing, integration testing. So if my microservice does nothing more than mostly interact with MongoDB, then my test should mostly test those interactions, those integrations with MongoDB. And what I also like about it, that it talks about testing in production. So what is testing in production? That is adding things like tracing, monitoring. Yes, these things are also very important, and they become much, much more important in a very big distributed system in a microservice world, because it isn't really possible to replicate my system in pre-production or locally, because those distributed systems become so big and it's not easy to really reason about all the things that can go wrong, which means you need to become better in monitoring, need to become better in testing in production. Okay, 2018, we have the blog post by Spotify about how Spotify does testing of their integration of their microservices, and they come up with the testing honeycomb. And that I like a lot, because this testing honeycomb says, okay, Spotify mostly does integration testing because their microservices mostly integrate and interact with other systems. So it makes sense for them to mostly have integration tests. They provide them much more robustness, better confidence, gives them more freedom to refactor. They can basically throw away the whole microservice, put in a new and keep the test suite. And what I personally liked, that in this article they mention that they use test containers to for this bulk of integration testing, to spin up the dependencies for these integration tests. They mention another thing, and that's called integrated test, and that is for me an interesting concept, because what does integrated test mean? These are things that we maybe classically often assume to be integration tests. These are tests that pass or fail independent of things that we are in control of. So if my tests run against a shared database that is shared by the whole team, and then my tests might fail because someone else is running the test at the same time, or another team is running tests that change the database schema or whatever, then these are mostly bad tests. These are called an integrated tests in this definition, and I want to avoid them. So that means I don't want to share resources, so I want to have better reproducibility. I want to have reproducibility of my environment. And that's where tooling like test containers then comes into play. We have variants of the same concept, so it's starting to get traction in the industry. We have this diamond model. Azaf presents this here at JavaZone. We have the testing trophy that came up in the JavaScript community, so basically the same honeycomb or diamond shape at the top, but another interesting addition at the bottom. Okay, static test, what does this mean? Static typing. So that we get for free in Java, but in dynamic languages, you have to add this. So, in a nutshell, what does this mean? So I personally think tests are a very, very multidimensional thing. So even we cannot define what are the difference between unit tests, what are integration tests. Why? Because it's not just one dimension. It's not just along the y-axis. So some dimensions I like to reason about is opaque box versus transparent box. So that means, can I look into my system under test, during the test, or after the test, or can I only look at the system from the outside through public APIs? Another good example is in-process test versus out-of-process test. Classical Spring Boot tests are in-process tests, because my tests are executed in the same JVM process as my application. But if I'm using, for example, something like REST Assured, I spin up my application, interact with it through the REST API, through over the wire, through an HTTP protocol, then it is an out-of-process test. And we have another cute concept here from Martin Fowler, solitary versus sociable tests. Solitary tests are tests that are like a completely isolated unit, and then you have to mock out all the dependencies, whereas sociable tests that also interact with its dependencies and potentially transitive dependencies. Right, so we will talk now more about concrete solutions for integration testing. How can we define integration test? For me personally, it's if my system interacts with external systems or external dependencies, mostly external processes. A database is an external process. File system is an external process. Kafka is an external process. And another nice addition here from Martin Fowler about what does it mean if you interact with external components from within your unit test. If talking to the resource is stable and fast enough for you, then there's no reason not to do it in your unit tests. Okay, so what we'll talk about here, instead of integration test, maybe you can also call it unit testing with real dependencies, whatever you want. But how do we get there? How do we get from the classical testing pyramid, where we mostly used unit tests because they are the ones that are cheap to write, cheap to maintain, cheap to run, to something where we leverage integration testing, leverage real dependencies to give us more confidence? So I like to repeat what Kent Beck and Eric Gamma said here. when they introduced forced the JUnit framework as a solution to getting people to write unit tests. We found the outside influence we need in a simple testing framework that lets us do a little testing that makes a big difference. So what is now the corresponding technology that makes a big difference and that helps you here? That's hopefully Testcontainers. And in a way, what Testcontainers tries to do is also coming back to what Venkat said in the beginning of the conference this morning. So it tries to not have you deal with a lot of accidental complexity of integration testing. It tries to provide you with the abstraction to make the integration, this accidental aspects of integration testing easy so you can focus on your actual testing part. How does Testcontainers now look like? So it's a Java library, open source Java library, an object-oriented API, and from anywhere in your Java code, for example, in your JUnit test, you can just instantiate a container object. You can configure it. Okay, what Docker image is it supposed to use? What kind of ports are supposed to be exposed? Then you start it. Then you test your system under test that potentially interacts with this dependency, and then at one point you can stop it, and then it gets cleaned up, and so on and so on. And there's a lot of stuff happening under the hood just in these couple of lines of code. So Testcontainers will automatically detect the Docker environment you are using, so you don't have to configure anything. Doesn't matter if you're using Docker desktop, you're using a remote Docker daemon configured with environment variables, you're using Docker desktop on Windows, on Mac, whatever. Testcontainers will detect this transparently at one point here. The starting will not only start the Docker container process, it will also wait for the application within the container to be ready, so it avoids any kind of race condition. And this with exposed host port will not map this port to the same fixed port on your host. So it's not like running -p 6379 :6379 on the command line. No, this is publishing it to a random free port, and then you have a convenient API to get the actual map port that you have to then inject into your system under test. Why do we do it like this? To avoid having integrated tests that would accidentally fail if this port is already blocked. So we automatically publish onto a free port. And there are also existing integrations with all the main Java frameworks. Java test frameworks here. This is the JUnit 5 version. So if you don't want to write start and stop by yourself, you can also use this JUnit Jupyter extension. Then you just use some annotations, and then this extension will manage the life cycle of the container. Either will start containers per method or per class. But a word of caution here, starting containers per method is of course quite expensive. Even starting them per test class sometimes can be expensive, and we have in the Testcontainers documentation a concept called singleton container patterns. So that is much better. That will just run the container instance once per JVM process. And if you're using Spring Boot and you're using the Spring Boot integration with Testcontainers, then Spring Boot manages the lifecycle for you. It's also much cheaper than for you. Okay, some infos about the project. Has been first released in 2015. 100% open source under MIT license, and it's nowadays, I would say, a de facto industry standard within the Java community, used by 20,000 other projects on GitHub, many stars. And yeah, so these three guys there, it's me, Sergey, and Richard, that were the original maintainers and authors of the project. Nowadays, I would say Edu on the bottom right here is the main maintainer responsible for Testcontainers Java. So if you are doing like creating issues or opening pull requests, you most likely would interact with him. And if you're not using Java, so there are also many variants of this library in other languages by now. So we have it for Go, .NET, Node.js, Python, Rust, Haskell, Ruby, so Haskell, that's curious, yes. We have wrappers for Clojure, for Scala. We have currently an incubating version for PHP even, and I think that's like most of what you need. Yeah, so quite popular, so always getting more stars. And it's if you compare it with the stars of a JavaScript project, it's maybe not that much, but the amount of stars for a Java project, it's quite good. And yeah, we are happily have been mentioned in the technology radar from ThoughtWorks as one of the technologies to adopt. So that's very cool. We think it's a useful default option for creating a reliable environment for running tests. Some of the features that Testcontainers brings to you is, support for any kind of Docker image, so anything that you can run in a Docker container, you can run through the Testcontainers API in a programmatic way. We have specialized support for many database technologies already, relational database, NoSQL databases, stream processing support for things like Kafka, Pulsar. We invested into support for vector databases if you're doing like a RAG or a GenAI stuff, support for Olama by now. When you integration test against clouds, that's always a challenge. So how do you test against the cloud without running the actual cloud components? So luckily there are some good cloud emulators out there like LocalStack, and also from GCP and Azure they provide certain, so we have modules for those. If you're already using something like Compose to achieve something in this vein, you can use your existing Docker Compose files with our Docker Compose integration. For UI testing, you can containerize the browser using also Testcontainers, so it will start a basically pseudo-headless browser that will render in a container, that will render everything into a virtual frame buffer. You can still record the session and so on for Selenium test or Playwright or whatever you're using. If you're into chaos testing, so where you, during your test, like turn down the network connection, drop packages, whatever, introduce latency, we have special support for ToxiProxy, for putting a ToxiProxy container between your application and the dependency. And even some special support for Kubernetes, and that depends on what you're doing with Kubernetes. It's for K3S and kind. That is, for example, if you're doing something like building a Kubernetes operator and you want to test if it successfully deploys into Kubernetes, then you can use this kind module to spin up the Kubernetes in Docker cluster. And many, many more other things. So some of the generic features are already showed or mentioned in this tiny code snippet. So we have support for this dynamic port binding. So never use fixed ports. That's our philosophy. Always use dynamic ports so that you don't run into this uncomfortable situation where a port you want to bind against is already in use. So instead, we publish onto a free port. Then you can just get it through a convenient getter, inject it into your system under test. With Spring Boot, it's kind of for free. That's integrated in Spring Boot nowadays. With other framework, Quarkus also works very well. Micronaut works very well. If you're in the Jakarta world, JE world, you maybe have to do it a little bit more manually, or if you're having your own application framework, you also have to do it manually. But in general, it's always possible to inject this port before your system under test starts, in my experience. We have this the discovery of the Docker environment built in, so you don't have to configure anything. If you have Docker installed on your machine, any variant of Docker, it will just work. Now, I always get the questions, what about Podman, what about Colima? So my diplomatic answer here is we support any Docker API compatible runtime. That means assuming Podman would have a Docker API compatible runtime, we would support it as well transparently. Since Podman differs in certain details from Docker, the experience might vary, I would say. But in general, you can get things working. Just with Docker, you have the best out-of-box experience. And it works on all operating systems. It doesn't matter, Docker desktop or natively installed on Linux or MCI or whatever. Okay, since some time we now have this module catalog. So if there are certain technologies you want to test against and you don't know how to configure the container for your test, like you have to maybe set certain environment variables, what are the waste residues, whatever, you can just use one of those ready-to-use modules, and that gives you an abstraction as a Java class, and you just say new Postgres container, new Couchbase container, whatever, you started, and then you're good to go. Okay, and I have 5 minutes time for a tiny demo, so let's do it. All right, so I have a small application that is on purpose framework free. So it's basically one repository class that can save book objects into a relational database, and I have a special offer class that sends out messages onto a Kafka topic. Okay, and now I want to first test my book repository class, and I want to test it against Postgres. So here I'm using the JUnit 5 extension to control the lifecycle. And the way I do it here, it will start a new container for each test method. So I have annotated the class with Testcontainers, I've annotated the container field with add_container, and here I'm using the Postgres module. So and that's all I have to do. I don't have to configure anything, I just say Postgres container, I say which image to use, good to go. Okay, I'm using Flyway to initialize my schema, and here we see some of the convenient methods that those modules also provide for you. So I said we always have this dynamically mapped port, which means you cannot statically code the JDBC URL under which the container will be reachable. That's why you can just get it after the container has started using this get JDBC URL method. So here I'm configuring Flyway to then interact correctly with this container. I'm calling Flyway migrate to initialize the schema. And then here are a couple of tests. So empty repository is empty. If I save something, there is something in the repository. If I save multiple things, there are multiple books in there. So let's just run it and see how it feels. And currently I have no database running locally, I have no Docker containers running, and yeah, so we see already the logs. So the first test is done. It's here 4 seconds, and so we see here in the logs this TC Postgres log. We see okay, we create a container, we start the container is successfully started after 3 seconds, and here container started doesn't mean Docker container has started, but semantically this Postgres container has started, means it is ready to interact with your application. And that's very important. And it's not always so trivial to find the right time when an application within a container is actually ready. In case of Postgres, if you start an empty Postgres database, Postgres process will start, will then bootstrap its internal database tables, and then it will restart its engine. So we have specific wait strategies implemented for these modules. In case of Postgres, we wait that database has been started appear 2 times in the logs. That's actually the most stable one. If you test for being able to make a JDBC connection, that is still a race condition, since you might succeed in it before the restart, and then it might restart, then your application wants to interact with it and could fail. Yeah, so we see here each test method is 4 seconds. It's kind of okay, but you see a little bit the price. Every time we create a completely new database, so it's a little bit of price to pay. You can quite easily optimize it already. If I make this here static, it will now become a container that is shared by the whole class. And then to make sure I don't have any issues with test data pollution, I'll just call Flyway clean before doing the migrate. Let's run it again. It should be faster now, especially the individual tests. So the first test will still take 4 seconds or something. It took 4 seconds, it's just not correctly reported now by IntelliJ here, but so we see they are then now down in the milliseconds, and I think that's pretty okay. So of course, if you use something like H2, it might be even faster. If you test it fully in memory, it might be even faster. But this gives you the confidence of doing the integration testing against your real database. And so I have another example here that I'm now not running, but I could, and that is using Oracle container. So if you're using an Oracle database, you can do the same. And especially when you're using Oracle, you might use SQL that is Oracle specific, because why else are you using Oracle? You want to use Oracle features. And I don't think you then want to maintain a set of SQL statements for the H2 or put H2 in emulation mode or whatever, and then have those tests, and they might fail later in CI. It's much, much more convenient to test against the real thing. Okay, and now as the last thing, let's do the same for Kafka. We see the same idea. We're using now here the Kafka module. I just have this object-oriented abstraction, new Kafka container. And similarly to this get JDBC method, I have this get bootstrap server method that gets here the map port. You can already inject it into your system. If I now run it, I will see some logs. Okay, yes, container created, container. Okay, so and it's done now. Took a little bit more because Kafka takes a little bit more to start than Postgres, but afterwards I'm good to go. And yeah, there is many, many more to learn when using Testcontainers. Just check out the documentation, check out other talks I gave about Testcontainers or our guides. And if you have also any questions, come to me, ask me, or join our Slack, ask in Slack, ask me on Twitter, whatever. Thank you very much. That's it. Yeah, and we're perfectly on time, so have a good trip home. Have a good rest of the weekend.